So, Hare Krishna student. Now this is my 9th video, and again I am continuing the inverse trigonometric function part 6. The last session I have told you that we have to take some unusual problems are there, isn't it? So day before this session we have taken the 5 unusual problem. Now continuing again the unusual problem, and that is again very important, isn't it? From the examination point of view, from the board, from the CET, also the J. Once you know the basic concept, you can proceed, isn't it? For the any problem you can deal with the any problem, isn't it? So again this is very important. Now I will take the one unusual, that is the inverse trigonometric function. Inverse trigonometric function part 6, that is unusual. Again, first one, y is equal to root of tan inverse root of 1 minus cos x root of 1 plus cos x divided by root of 1 minus cos x minus root of 1 plus cos x. Right? Now again the problem is, what can you do? Again you have to use the evergreen formula, because 1 minus cos x, 1 plus cos x. Therefore at once you have to try. That is what here? Evergreen formula. It's again very important. Now this is tan inverse. Here 1 minus cos x you can write as a 2 sin square x by 2. 1 plus cos x you can write as a 2 cos square x by 2. Here again, this is 2 sin square x by 2 and minus 2 cos square x by 2. Right? Again, y is equal to tan inverse root 2 remain as it is, and the square root of sin square x by 2, that is equal to sin x by 2. Again, this root 2 remain as it is. This is cos x by 2, the square root of cos square, again root 2, sin x by 2, and here again root 2, cos x by 2. Right? Now root 2 you can take common. Here also root 2 you can take common. That is get eliminated. You cancel it, and what is remain here? Sin x by 2 plus cos x by 2 divided by sin x by 2 minus cos x by 2. Right? Now see, divide both numerator and denominator by here sin x by 2. If you divide it with sin x by 2, see what you have got here. Y is equal to tan inverse 2 numerator and denominator. When you divide it with sin x by 2, you will get 1. This is cot x by 2. Here also 1 minus cot x by 2. Again if you observe this, 1 it is strictly there, and the multiplication of this 2 term, it is there. Therefore you can use the formula, that is tan inverse of 1 plus simplified form of this formula, tan inverse of cot x by 2. Again y is equal to tan inverse 1 remain as it is. Here again there is a tan inverse, and in bracket there is a cot. Therefore what you have to do? Tan inverse. Cot you can convert it in the form of a tan, again by taking the help of a pi by 2. This you can write as a pi by 2, tan of pi by 2 minus x by 2. Right? Here again y is equal to tan inverse 1. Tan inverse tan get cancel. Pi by 2 minus x by 2 dy by dx. Tan inverse 1, it is totally independent of x, considered as a constant, and the derivative of a constant function, it is always equal to 0. The derivative of a pi by 2, again 0, and here minus 1 by 2 remain as it is, and the derivative of x, that is equal to 1. Right? So again the unusual problem. See, tan inverse root of 1 minus cos x root of 1 plus cos x. Here also root of 1 minus cos x minus root of 1 plus cos x. Here you can change this. You can bifurcate this angle. In place of x, you can substitute 2x, 3x, 4x, 100x. x by 2, x by 4, any angle you can choose. But the angle throughout here must be same. If there is x by 4, here also you have to write x by 4. Here also you have to write x by 4. Here also you have to write x by 4. So, remembering the basic concept. What is the basic concept? Here you have to use the evergreen formula 1 minus cos x, 1 plus cos x. That is very, very important. Right? Now, the bifurcation is there. Means sometimes you will get the problem like this. Here 3x, here 3x. Then you have to use, if 1 minus cos 3x, 2 sine square 3x by 2. If there is a 1 plus cos 3x, you have to use 2 cos square 3x by 2. Isn't it? So, in this way, you can bifurcate the formula, right? So, the first unusual problem of this session, isn't it? Now, second one, see. Second one. Y is equal to tan inverse root of 1 plus sine x by 2 plus root of 1 minus sine x by 2 root of 1 plus sine x by 2 minus root of 1 minus sine x by 2. See here. Again you know the formula, that is 1 plus sine x or 1 plus sine 2x. You can write as a cos x plus sine x whole square. Isn't it? 1 plus sine x you can write as a cos x by 2 plus sine x by 2 whole square. Isn't it? And if there is a minus sign, you have to write minus. If there is a x, you have to write x by 2. And if there is a x by 2, see here, suppose there is a x by 2, then what is the half of x by 2? That is equal to x by 4. Therefore, here you have to write cos x by 4 plus sine x by 4 whole square. Because if there is a 2x, there is a x. If there is a x, x by 2. If there is a x by 2, again, what is the half of x by 2? That is nothing but x by 4, right? Therefore, here you have to use this formula, see here, tan inverse. Here you can write cos x by 4 plus sine x by 4 whole square, right? Plus cos x by 4 minus sine x by 4 whole square. Root of cos x by 4 plus sine x by 4 whole square minus cos x by 4 minus sine x by 4 whole square. Right? Now see again. Y is equal to tan inverse. What is the square root of this? Cos x by 4 plus sine x by 4. Here again, what is the square root of this here? Cos x by 4 minus sine x by 4, right? Divided by, here again cos x by 4 plus sine x by 4. Here again cos x by 2 minus sine x by 2, but there is a minus sign out of this bracket here. Therefore, what is the square root here? Cos x by 2 minus sine x by 2. But since there is a minus sign, you can change the sign. That is, you have got as a minus cos by 2, cos x by 4, sorry, cos x by 4 minus of minus plus cos sine x by 4, right? See, since there is a minus sign, you have to change the sign here, because you have got, that is cos x by 4 minus sine x by 4. When you multiply with minus sign, here you have got cos x by 4 and minus minus plus sine x by 4, isn't it? See here again. This get cancelled. Minus sine x by 4 plus sine x by 4. Minus cos x by 4 plus cos x by 4 get cancelled. What is remain here? See. Here y is equal to tan inverse again. Cos x by 4 plus cos x by 4, you have got as a 2 cos x by 4, and here in the denominator sin x by 4 plus sin x by 4, 2 sin x by 4. 2 to get cancelled. Y is equal to tan inverse. Here you have got cos divided by sin, that is nothing but what here? Cot x by 4. Right? Y is equal to tan inverse. Again there is a tan inverse, and in bracket there is a cot. Therefore cot you can convert in the form of a tan by taking the help of a pi by 2. Pi by 2 minus x by 4. Here again tan inverse tan get cancelled. Y is equal to pi by 2 minus x by 4. Right? Therefore dy by dx, it is the derivative of a pi by 4 0 minus 1 by 4 remain as it is, and the derivative of a x, that is equal to 1. This is the second unusual one. Right? Now see the third. These are the very important problem. Now I will take the third. See, third one. Y is equal to sine of 2 tan inverse root of 1 minus x divided by 1 plus x. Right? Now see this problem. Again this is the unusual one. Here you have to substitute. What you can substitute again? I have already told you that you have to make such a substitution so that you should get the square term in the square root. Then and only then you can find out the square root. Therefore what you can substitute here? Suppose you substitute x is equal to cos theta. Again you know the evergreen formula, 1 minus cos theta, 1 plus cos theta. Isn't it? Therefore here theta is equal to what? Cos inverse of x, and you can substitute cos theta. Sine of 2 tan inverse, here 1 minus cos theta divided by 1 plus cos theta. Right? Now y is equal to sine of 2 tan inverse of, here again the evergreen formula, 1 minus cos theta 2 sine square theta by 2, and 1 plus cos theta 2 cos square theta by 2. Right? Again 2 get cancelled. Y is equal to sine of 2, again tan inverse, the square root of sine square theta by 2 and the square root of cos square theta by 2, that is sine theta by 2 divided by cos theta by 2, means here you have got tan theta by 2. Right? Again tan inverse tan get cancelled. Sine of 2 into theta by 2. Right? 2 get cancelled. Y is equal to sine theta. Now the student at once finded the derivative dy by d theta, it is equal to cos theta. But we want to differentiate with respect to x because every time you have to make the differentiation with respect to x. And here you have got the function theta. Can you differentiate dy by d theta? Dy by d theta, it is equal to cos theta? No, because we want to differentiate with respect to x. Right? Therefore the right hand side must be in the form of a x, then and only then you can differentiate with respect to x. Therefore the sine theta first you have to convert in the form of a what here? X. Isn't it? Now you know cos theta is equal to x. Now what is the sine theta? You know the identities here. Sine square theta plus cos square theta, it is equal to 1. Therefore sine square theta plus x square, it is equal to 1. Therefore sine square theta, it is equal to 1 minus x square, and sine theta is equal to root of 1 minus x square. Isn't it? Therefore in place of sine theta you have to substitute what here? Root of 1 minus cos square theta, and root of 1 minus cos square theta, it is nothing but root of 1 minus x square. Therefore y is equal to root of 1 minus x square. Now you can differentiate. Here again you have to apply the chain rule. What is the derivative of a root u? 1 upon 2 root u means 1 upon 2 root 1 minus x square, and the derivative of a minus x square, that is equal to minus 2x. 2 get cancelled, minus x divided by root of 1 minus x square. Right? So this is little bit what here? Tricky. Therefore it is the unusual example. Right? So such a type of example again you have to make the practice and practice. Right? बऱ्याचदा करून पाहायचे ते example. तरच तुमच्या लक्षात येईल. नाहीतर मग इथे परत डायरेक्टली यू कॅन राईट dy by d theta it is equal to cos theta, right? So you have to be very careful while making the while performing the differentiation, right? Whenever you have to differentiate with respect to x, the right hand side must be in the form of x. Then and only then you can differentiate with respect to x. Now again I will take the fourth unusual in this session. Fourth unusual, see. Fourth, here again y is equal to sin square cot inverse 1 plus x divided by 1 minus x, right? Sin square cot inverse 1 plus x, right? The type is little bit same here. Again what you can do here, x is equal to cos theta, right? Therefore theta is equal to cos inverse of x. Y is equal to sin square cot inverse root of 1 plus cos theta, here 1 minus cos theta, right? Therefore y is equal to sin square cot inverse, again use the evergreen formula, 1 plus cos theta, that is 2 cos square theta by 2, 1 minus cos theta, 2 sin square theta by 2. 2 to get cancel, y is equal to sin square cot inverse, again the square root of cos square theta by 2, that is cos theta by 2, and the square root of sin square theta by 2, that is sin theta by 2. Therefore cos theta by 2 divided by sin theta by 2, it is nothing but cot theta by 2, right? So again here you have got, that is y is equal to sin square cot inverse cot get cancel and theta by 2. Again don't differentiate with respect to theta. So again here you have got y is equal to sin square theta by 2. Again don't differentiate with respect to theta, because we want to differentiate with respect to x. Again the problem is this you have to convert in the form of a x. Now you know what is cos theta, that is equal to x, right? The cos theta it is equal to x. Therefore this sin theta also you can convert in the form of x, because you know that is 1 minus cos theta, it is equal to, see, 1 minus cos theta is equal to 2 sin square theta by 2, right? Or therefore 1 minus cos theta divided by 2, it is equal to sin square theta by 2, right? And again sin square theta by 2 is equal to, you can write as a 1 minus, what is cos theta, x. Therefore here sin square theta by 2 you can write as a 1 minus x divided by 2, right? Therefore in place of this sin square theta by 2 you can write as a y is equal to 1 minus x divided by 2. Again dy by dx, 1 by 2 remain as it is, the derivative of a 1 0 and the derivative of a minus x, that is equal to minus 1, and the result is minus 1 by 2, isn't it? Therefore here again this is the fourth unusual one and very very important. Y is equal to sin square cot inverse root of 1 plus x divided by root of 1 minus x. Here you have to substitute cos theta and use the evergreen formula whenever you have got y in the form of a theta. Therefore don't differentiate here. At this point you have to remember, don't differentiate directly with what here theta, that the function which is in the form of a theta, first you have to convert in the form of a x, and then and only then you have to differentiate, isn't it? Again the fifth unusual one, see, fifth unusual, these are all the unusual one here. Y is equal to fifth tan inverse root 3 3 minus x 1 minus 3x. This is very simple. Again we have done already this problem, right? But little trick, see, here again here x root x 3 minus x and 1 minus 3x. What can you do here? See, You can multiply with what here? Root x to this bracket. Here again 3 root x. Here x root x and divided by 1 minus 3x. Right? Now again if you observe this, tan inverse 3 root x. Here this you can write as a root x whole cube. And here in the denominator, this x you can write as a root x whole square. We have done this problem already in what here? The triple angle formulas. Again what you can substitute? Root x is equal to tan theta. Right? Therefore theta is equal to tan inverse of root x. Here y is equal to tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Right? Here again, this is the formula of what? Tan 3 theta. Again, tan inverse tan get cancelled. What is remain? 3 theta. Y is equal to 3. What is theta? Tan inverse of root x. Therefore, dy by dx. 3 remain as it is. Again apply the chain rule. What is the derivative of a tan inverse u? 1 upon 1 plus x square means 1 upon root x square means x, and the derivative of a root x, that is equal to 1 upon 2 root x. This is about the fifth unusual one. Now I will take the sixth. See. Sixth one, y is equal to, again tan inverse, root of, here, again root of 1 plus x square plus x and root of 1 plus x square minus x, right? And here again tan inverse. Again what can you do? I have already told you, whenever there is a 1 plus x square, what you can substitute? If you substitute x is equal to tan theta, then 1 plus tan square theta, that is equal to sec square theta. Right? Therefore, substitute here, x is equal to tan theta, therefore theta is equal to tan inverse of x. Y is equal to tan inverse, this is big root, and this is root of 1 plus tan square theta. Again plus tan theta, here in the same root 1 plus tan square theta and minus tan theta. Right? You know 1 plus tan square theta, that is equal to sec square theta, and the square root of sec square theta, that is equal to sec theta. Here again sec theta plus tan theta. Here you have got 1 plus tan square theta, that is sec square theta, and the square root of sec square theta, again sec theta and minus tan theta. Again what can you do here? Only the choice is to make the conversion, because there is no any such a formula. The sec you can convert in the form of a cos, 1 by cos, and the tan you can write in the form of a sin by cos. Right? Here also in the root 1 upon cos theta sec and minus sin by cos. Right? Now the denominator is same directly at the numerator, therefore y is equal to, that is the square root of, here denominator is same, that is cos theta, therefore here you have got 1 plus sin theta divided by cos theta, and in the denominator 1 minus sin theta divided by cos theta. Right? Again cos theta get cancelled, y is equal to tan inverse root of 1 plus sin theta divided by 1 minus sin theta. And such a type of a problem we have already done, isn't it? Tan inverse. Again this you can write as a, see, 1 plus sin theta you can write as a cos theta by 2 plus sin theta by 2 whole square, and here cos theta by 2 minus sin theta by 2 whole square. Right? Therefore, out of square root, you have got as a cos theta by 2 plus sin theta by 2 Here again cos theta by 2 minus sin theta by 2. Again as usual, what you have to do? You have to divide it with what here? I will here. You have to divide it. Divide both numerator and denominator by what here? Cos theta by 2, isn't it? Now whenever you divide cos theta by 2, see here, y is equal to, the space is small here, see. So please see carefully here, tan inverse. Now when you divide it with cos theta by 2, you have got as a 1 plus tan theta by 2 divided by 1 minus tan theta by 2, right? Again, here, what is the formula? You can use tan of pi by 4 plus theta by 2, or you can write 1, it is strictly there, and the multiplication of a 2 term is there, therefore you can use the second formula or the first one also. Tan inverse, tan of pi by 4 is the compulsory term. If there is a plus in the numerator, write plus, and whatever the angle, that is theta by 2, you can write theta by 2. Again tan inverse, tan get cancelled. This is pi by 4 plus theta by 2. But again, you have to differentiate with respect to x. Therefore, the theta you have to convert in the form of a x, that is y is equal to pi by 4. 1 by 2 remain as it is, and the theta, it is nothing but tan inverse of x. Therefore, dy by dx, the derivative of a pi by 4, that is 0. 1 by 2 remain as it is, and the derivative of a tan inverse x, 1 upon 1 plus x square. So this is the result, and this is the sixth unusual one, right? Don't get confused. Though there is a root, अगर रूट में रूट है तो भी घबराने की कोई ज़रूरत नहीं. Here 1 plus x square, you know what you have to do. When you substitute 1 plus x square, that is x is equal to tan theta, you will get the square term in the root, and you can take that term out of the root, and the problem get simplified and problem get easy for you, isn't it? So now the seventh one, see, seventh unusual, very very important. Seventh, that is y is equal to cot inverse 4 minus x minus 2x square divided by 3x plus 2. See, again, very unusual. First, your duty is to convert cot in the form of a tan. Cot inverse you can convert in the form of a tan inverse by taking the reciprocal of a angle, right? Now here 4 minus x minus 2x square, right? Here again, what you have to do? How will you imagine this? So this is a quadratic, and here there is no any such a formula, isn't it? So therefore you have to remember what is the formula here. If tan inverse x plus tan inverse of y, then it is tan inverse of x plus y divided by 1 minus xy, right? In this way you have to here imagine. So since this is a quadratic, you can find out the factor, but in this formula 1 should be strictly there. Therefore first you have to write here 3x plus 2. Here 1 should be strictly there. Therefore 1 add plus 4 minus x minus 2x square, and here what here, that is equal to minus 1, isn't it? Now again, y is equal to tan inverse 3x plus 2. 1 should remain as it is. Again 4 minus 1, that is 3. Therefore 3 minus x minus 2x square, right? Again to find out the factor, see what you have to do. This is 3x plus 2. Now 1 should remain as it is. Now you can take minus sign common. If you take minus sign common, 2x square plus x minus 3 you have got, isn't it? Now see what you have to do. Here you have to find out the factor of that quadratic function. See what are the factor of this quadratic function. Here 2x square plus x minus 3. Here 2 and 3. 2 and 3, these are simply factor. Therefore this x you can write as a 2x square plus 3x minus 2x minus 3. Isn't it? Now whenever you take x common, what is remain? 2x plus 3. And if you take minus sign common, you have got 2x plus 3. Isn't it? Therefore the factors are 2x plus 3 and x minus 1. Now you want to adjust this factor so that their addition or subtraction. Since there is a subtraction in the denominator, therefore there is a addition of this two factor must be in the what here numerator. Therefore to get 3x, you can 2x plus x, that is equal to what here 3x, and 3 minus 1, that is equal to 2. Therefore in place of 3x plus 2, you can add this two factor, that is y is equal to, you can write as a 2x plus 3 plus x minus 1, right? Therefore 2x plus x, that is equal to 3x, and 3 minus 1, that is equal to 2, right? And the multiplication of this two factor, it is nothing but what here? 2x square plus x minus 3. Therefore 1, these are the two factor, that is 2x plus 3 and x minus 1. Now your problem, it is in a standard formula. One, it is strictly there, and whatever the term added in the numerator, we want its multiplication in the denominator. So that thing is already there. 2x plus 3, x minus 1, their multiplication and their addition, right? Now here you can separate this, that is tan inverse of 2x plus 3 plus tan inverse of x minus 1. Again very very important here, dy by dx. What is the derivative of a tan inverse u? 1 upon 1 plus u square, means 2x plus 3 whole square. Don't simplify, right? What is the derivative of a 2x? 2, and the derivative of a 3 is 0. Again 1 upon tan inverse u, 1 upon 1 plus u square, means x minus 1 whole square, and the derivative of a x1 and the minus 1, that is 0. So this is about the seventh unusual one, and this is again very very important, right? Again I will take the eighth here, eighth unusual. See, eighth unusual, that is y is equal to cot inverse a square minus 6x square divided by 5uax. Right? Again first, what is your duty? First you have to convert the cot inverse in the form of a tan inverse. Therefore tan inverse, this you can write as a 5uax divided by a square minus 6x square. Again how will you imagine? Again you want one, strictly one, therefore divide both numerator and denominator by what here? A square. When you divide it with a square, see what you have got. When you divide it with a square, you have got 5x by a, and here 1, and here you have got minus 6x square divided by a square, isn't it? Since there is a minus, therefore you have to adjust 5x by a in such a way that the sum of the two term must be equal to the product of this. The sum of the two term, whatever the term you are going to add it, their multiplication should be in the denominator, that is 6x square divided by a square. So how will you consider this term, that is the 5x by a? How will you write? In the form of a two term, so that their addition must be 5x by a, but their multiplication must be 6x square divided by a square. Again quite simple, very simple here. This you can write as a 3x by a plus 2x by a, right? Now see, if you observe this, their multiplication, if you multiply these two terms, 3x by a into 2x by a, 3 2s are 6, x into x, x square, a into a square. You have got this, right? Again using the formula tan inverse, this you can write as a 3x by a and plus tan inverse 2x by a, right? Again dy by dx, the derivative of a tan inverse u, that is 1 upon 1 plus u square, means 9x square divided by a square, and ddx of 3x divided by a, right? Again 1 upon 1 plus u square, means 2x 2 square means 4, x square means x square, a square, and d dx of 2x divided by a, right? Again cross multiplied. When you cross multiply to a square and again a square, it is in the numerator, you will get a square plus 9x square into 3 by a, constant term remain as it is. When the constant, it is multiplied to the function, constant remain as it is, and the derivative of x, that is equal to 1, isn't it? Again here cross multiply and a square, it is in the numerator, a square 4x square, 2 by a remain as it is, the derivative of x, that is equal to 1. Again 1a get cancel, here also cancel. What is remain? 3a divided by a square plus 9x square and 2a divided by a square plus 4x square. Again this is the 8th unusual problem, right? So this is also very, very important. Little bit you have to imagine it, isn't it? So you get confused. First the cot inverse, strictly you have to convert in the form of a tan inverse, and then you have to imagine whether there is a formula of a tan 2 theta or whether there is a formula of a tan inverse x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Whatever the formula is on tan, that you have to remember yourself, isn't it? Tan 3 theta, no question of this here. Therefore you have to judge which formula you can imagine here, you can apply yourself, right? Now I will take the 8th unusual one. 8th, see here, y is equal to tan inverse 2 x to the power 5 by 2 and 1 minus x square 5, x to the power 5. It's very simple, 2 is there, see. Therefore directly you can imagine yourself, this must be a formula of a tan 2 theta. What is the formula of a tan 2 theta? That is 2 tan theta divided by 1 minus tan square theta, isn't it? Therefore by seeing this term, you have to judge it, which formula you have to use here, right? Therefore tan inverse, this is 2 x to the power 5 by 2, but here this x to the power 5 you have to adjust like this, x to the power 5 by 2 whole square. Then and only then you can substitute x to the power 5 by 2 is equal to tan theta, right? And theta is equal to tan inverse of x to the power 5 by 2, right? Now if you substitute, y is equal to tan inverse, this is 2 and this is nothing but what here, tan theta divided by 1 minus tan square theta, right? Now y is equal to tan inverse, here again 2 tan theta divided by 1 minus tan square theta. This is the formula of tan 2 theta. Tan inverse tan get cancel. What is 2 theta? Y is equal to 2 and theta, it is nothing but tan inverse of x to the power 5 by 2, right? dy by dx, 2 remain as it is. Here again substitute u. What is the derivative of a tan inverse u? 1 upon 1 plus u square, means 1 upon 1 plus x to the power 5 by 2 whole square and d dx of x to the power 5 by 2, right? Now there you have got as a 2 divided by x to the power 5 by 2 whole to the power 2, 2 to get cancel, x raised to power 5. And what is the formula here? What is the derivative of x to the power n? N into x to the power n minus 1. Therefore 5 by 2 x to the power 5 minus 2, 3 by 2. 2 to get cancel, here 5 x to the power 3 by 2 divided by 1 plus x to the power 5. Right, again the 8th unusual one. Now I will take the 9th one, see, right? The 9th one, again little bit tricky. Here y is equal to sine inverse 4 raised to x plus 1 by 2 divided by 1 plus 2 raised to 4x, isn't it? Now see this one, this problem, right? Here you have to first simplify this, the term in the bracket. First you have to simplify this. Now this here you can write as a sine inverse Whenever you have to separate this first, 4 raised to x and 4 raised to 1 by 2, isn't it? Because the power of this 4, that is x plus 1 by 2, therefore you have to use the laws of indices, right? That is 4 raised to x and 4 raised to 1 by 2. When the base is same, you can add the indices, isn't it? Therefore 4 raised to power x and 4 raised to power 1 by 2, isn't it? Again this you can write as a 2 raised to 4 whole to the power x. Alright, first you have to adjust like this. Now sine inverse. Here again, 4 raised to 1 by 2 means what here? That is the root of 4. And the root of a 4, it is nothing but 2. 2 into 4 raised to x. And here, the 2 raised to power 4, it is nothing but 16. 16 to the power x. Right? By seeing this 2, again you should know which formula you have to use. That is 2 sine 2 theta, it is nothing but 2 tan theta divided by 1 plus tan square theta. Right? Therefore, here you can write sine inverse. This is 2, 4 raised to x. And here you can write 1 plus 16 to the power x, you can write as a 4 raised to x whole square. Now you can substitute 4 raised to x is equal to tan theta. Therefore, theta is equal to tan inverse of 4 raised to x, right? Therefore, here y is equal to sine inverse, here 2 tan theta divided by 4 raised to x whole square means 1 plus tan square theta. Again, this is the formula of sine 2 theta, sine inverse sine 2 theta, right? Again, sine inverse sine get cancelled. What is remain? 2 theta. Y is equal to 2 tan inverse of 4 raised to x. Right? Therefore, dy by dx, 2 remain as it is. Here you can substitute u. The derivative of a tan inverse u, it is nothing but 1 upon 1 plus u square means 4 raised to x whole square and ddx of 4 raised to x. The derivative of a raised to x log a. The derivative of a 4 raised to x, 4 raised to x log 4 means here you have got 2, 4 raised to x log 4. And you know 4 raised to x you can write as a 16 to the power x. Right? Because you can exchange the power, 4 square means 16, 16 to the power x you can write. So this is about the 9th unusual one. Now I will take the 10th. Right? See. The 10th one. Here again. Y is equal to sine inverse 1 minus x cube divided by 1 plus x cube. Again the confusion. See, think about this problem. You can't get any idea, isn't it? So what can you do? 1 minus x cube, 1 plus x cube. Right? It is likely that is 1 minus tan square theta divided by 1 plus tan square theta. Right? But x cube you can't substitute as a tan square theta, isn't it? Because you want the value of that here. See, therefore what you can do, you can make such a simple adjustment. You can write this 3 by 2 whole square, isn't it? Now 1 plus x to the power 3 by 2 whole square. Now you can write here, see, x to the power 3 by 2, it is equal to tan theta. Right? Therefore, theta is equal to tan inverse of x to the power 3 by 2. Right? Therefore, here you have got y is equal to sine inverse. This is 1 minus tan square theta. Because x to the power 3 by 2, it is nothing but tan theta. That is tan theta whole square means tan square theta. Here 1 plus tan square theta. And again, if you observe this, 1 minus tan square theta divided by 1 plus tan square theta. This is the formula of a cos 2 theta. Isn't it? Again, there is a sine inverse and in bracket cos. The cos you have to convert in the form of a sine by taking the help of a pi by 2. Pi by 2 minus 2 theta. Right? Sine inverse sine get cancelled. What is remain here? Pi by 2 minus 2 theta. Therefore, y is equal to pi by 2 minus 2. What is theta here? Theta, it is nothing but tan inverse of x to the power 3 by 2. Right? 3 by 2. again dy by dx. The derivative of a pi by 2 0. Minus 2 remain as it is. Here again you have to substitute u. The derivative of a tan inverse u, that is 1 upon 1 plus u square, means 3 by 2 whole square, and d dx of x to the power 3 by 2. Right? Again minus 2 divided by 1 plus 2 to get cancel x cube. What is the derivative of x to the power 3 by 2? 3 by 2 x to the power 1 by 2. 2 to get cancel. Here you can write minus 3. X raised to 1 by 2, it is nothing but root x divided by 1 plus x cube. This is about the 10th unusual one, right? These are the very, very important one. And here again, I will take the 11th. That is, see, this y is equal to tan inverse 2 raised to x divided by 2 raised to x divided by here 1 plus 2 4 raised to x. This is the problem, that is 2 raised to x divided by 1 plus 2 x to the power 4 to the power x. Right? Now again, see, what can you do? Again little bit this here. Now here 1 it is strictly there. Therefore, here again you have to make the adjustment. This is 2 raised to x, and here again 1 plus 2, and 4 raised to x you can write as a 2 raised to x whole square. Right? Therefore, you have to adjust this term. There is a plus. You have to choose the two term such a way that their subtraction must be 2 raised to x and their multiplication must be, that is 2 into 2 raised to x whole square, isn't it? So, which two term you can use here? So that their subtraction must be 2 raised to x and their multiplication must be 2 into 2 raised to x whole square. Right? Which two terms are there? That is, see, you can write this 2 into 2 raised to x minus 2 raised to x. 2 into 2 raised to x minus 2 raised to x. Their multiplication, it is nothing but 2 into 2 raised to x into 2 raised to x, means 2 into, that is 2 raised to x, 2 raised to x, that is equal to what here? 4 raised to x, isn't it? 4 raised, this is 2 raised to x, 2 raised to x, means 2 raised to x plus x, 2x, and this you can write as a 2 square, means what here? Here you can exchange the power 2 raised to x whole square, isn't it? Here such adjustment are there, that is 2 into 2 raised to x whole square. If you choose this two term, you will get this, their multiplication, because see, 2 into 2 raised to x into 2 raised to x, multiplication of this two term, right? 2 into 2 raised to x into 2 raised to x. The base is same, you can add indices. Therefore, here you have got 2 to the power 2x, right? Again, 2 to the power 2x, 2 to the power 2x, you can exchange the power like this, 2 raised to x whole raised to 2. Therefore, here you have got this term. Therefore, the 2 raised to x, you can adjust like this, right? Divided by 1 plus 2 into 2 raised to x whole square. Now, it's very simple. 1 it is strictly there, and the multiplication of this two term is here, there. Therefore, y is equal to tan inverse. Here, you can write as a 2 into 2 raised to x minus tan inverse of 2 raised to x. Right? Again, y is equal to tan inverse of, since the denominator, the base is same, you can add the indices 2 raised to x plus 1, because the power it is 1, right? Minus 2 raised to x. Again, it's very simple. dy by dx. What is the derivative of a tan inverse u? 1 upon 1 plus u square, means 2 raised to x plus 1 whole square. What is the derivative of a 2 raised to x plus 1? 2 raised to x plus 1 into log 2. Again here, 1 upon 1 plus 2 raised to x whole square, means 4 raised to x, and the derivative of a 2 raised to x, that is 2 raised to x log 2. Right? So here I have finished the 11th unusual problem, and the last session we have finished, that is the 5 unusual problem. Therefore the total, that is the 16 unusual problem. And here I have finished the inverse trigonometric function. That is very vast, and we required, how many parts are there? 6 parts. Part 1, part 2, part 3, part 4 and part 6. Right? And only one exercise it is given in your book. And so many different type of a problems are given. That is mixed problem given in the exercise. You can't solve at once unless and until you don't see the variety, or you don't understand the variety of your problems, right? Now you can solve yourself the exercise in your textbook, right? So this is the vast, that is the inverse trigonometric function, right? So the student, if you like my video, please share it and subscribe my channel. And again, give the comments in the comments box. Give me the suggestion if you want, that I am going to accept it, and your whatever the questions or whatever the suggestion I am going to tell you, isn't it? I will accept it and I will solve your problem.